Let me tell you a story about the biggest mistake humanity makes when trying to understand the universe. It's not a miscalculation. It's not a lack of equipment. It's something much more fundamental, more human. And ironically, it's the same mistake that prevents us from understanding not only physics, but practically everything in life. The mistake is this: we trust our senses too much. Now, before you think, wait a minute, our senses are all we have, let me explain what I mean. Imagine you were born and raised inside an elevator. This elevator never stops. You've never seen the world outside. Everything you know happens inside this metal box. One day you drop an apple from your hand, and it falls to the floor. You repeat this 1,000 times. The apple always falls. So you create a law. Apples fall. Simple, direct, based on pure observation. But here's the problem. You don't know if the elevator is stationary on Earth, moving upwards at a constant speed, or floating in space with an acceleration exactly equal to Earth's gravity. For you, inside the elevator, these three situations are absolutely indistinguishable. Your senses tell you exactly the same thing in all three cases. The apple falls at the same speed, makes the same noise when it hits the floor. Everything is identical. This is the fundamental error, assuming that what our senses tell us is the whole of reality. And you know what's craziest? It took humanity millennia to realize this. Millennia. Aristotle, one of the most brilliant minds of antiquity, looked at the world and said, "Heavy objects fall faster than light objects." Why? Because that's what seems to happen when you drop a stone and a feather at the same time. The stone hits the ground first. Direct observation. Case closed. There's just one problem. Aristotle was completely wrong. But wait, why was he wrong if that's exactly what we see happening? Here's the key. Aristotle wasn't seeing gravity. He was seeing gravity and air resistance together, but his brain couldn't separate the two effects. It's like trying to listen to a specific song at a crowded party. What you hear is all mixed together: the music, the conversations, the clinking of glasses. Your ear can't automatically filter out just the music. It took almost 2,000 years until a stubborn Italian named Galileo said, "Wait a second, what if we take the air out of the equation?" He imagined, and eventually demonstrated, that in a vacuum, without air resistance, a feather and a stone fall at exactly the same speed. The difference we see in everyday life is not a fundamental property of gravity, it's a secondary effect of the atmosphere. And you know what's even more impressive? When the Apollo 15 astronauts went to the moon, one of them performed exactly that experiment. He dropped a feather and a hammer at the same time, and on the moon, where there is no atmosphere, they fell side by side, hitting the lunar surface at the exact same instant. Galileo was right 400 years ago, but we could only see it with our own eyes when we went to another world. This brings us to the heart of the problem. Our senses evolved to keep us alive on the African savanna, not to understand the fundamental structure of the universe. They are optimized for detecting predators, finding food, recognizing faces. They are tools for survival, not instruments of scientific precision. Imagine this. You're walking down the street at 5 kilometers per hour. You feel the wind on your face. You feel your feet touching the ground. You feel the sun on your skin. Everything seems solid, static, absolutely real. But the physical reality is completely different and much more bizarre. First, you are not standing still in space. The Earth is rotating at approximately 1,600 kilometers per hour at the equator. At the same time, the Earth is orbiting the Sun at 107,000 kilometers per hour. The Sun is orbiting the center of the Milky Way at 720,000 kilometers per hour, and the Milky Way is moving through space at more than 2 million kilometers per hour. Right now, you are traveling through the universe at speeds that would make any spaceship seem like a snail. But do you feel anything? Nothing. Zero. Your senses tell you that you are practically standing still, perhaps walking slowly down the street. Second, the ground beneath your feet. It looks solid, right? It looks like matter, substance, something real and impenetrable. But if you could zoom in infinitely, what would you see? Atoms. And atoms are almost completely empty. The nucleus of an atom is tiny compared to the total space of the atom. If the nucleus were the size of a tennis ball in the center of a football stadium, the electrons would be swirling around in the stands. This means that you, the ground, everything you touch, is 99.9999% empty space. You are, essentially, a cloud of electrical charge that repels other clouds of electrical charge. When you touch something, you never really touch it. The electrons in your hand repel the electrons in the object. It's a sensation created by electrical forces, but your senses tell you, this is solid, this is real, this is substantial. And here's the mistake. We use these sensations as a starting point to understand the universe. It's like trying to understand how a computer works just by looking at the screen. You see images, text, videos, but that tells you nothing about processors, RAM, binary code, electricity flowing through circuits. The screen is an interface, not the underlying reality. Our senses are an interface with reality, not reality itself. Now, let me show you how this error manifests itself even more profoundly with an example that will fry your brain. The speed of light. Imagine you are standing at a train station. A train passes by at 100 kilometers per hour. Inside the train, someone shines a flashlight ahead, in the direction the train is traveling. The light from the flashlight travels at 300,000 kilometers per second. Let's round it off for simplicity. Simple question. At what speed is the light traveling from your point of view standing at the station? Your instincts, based on all your life experience, tell you, well, 100 kilometers per hour of the train plus 300,000 kilometers per second of light. Just add it up. And if it were a ball that the guy on the train threw forward, you would be absolutely right. The speed of the ball relative to you would be the speed of the ball plus the speed of the train. That makes perfect sense. But what about light? It doesn't work like that. Light travels at exactly 300,000 kilometers per second, both for the person inside the train and for you at the station. The same speed. It doesn't matter if the train is stopped, if it's going at 100 kilometers per hour, or if it's going at 99% of the speed of light. Light always travels at 300,000 kilometers per second for all observers. This makes absolutely no sense. It violates everything your senses tell you about how the world works. It's like you're driving down the road at 100 kilometers per hour, and a car overtakes you at 120 kilometers per hour. From your point of view, it should be going 20 kilometers per hour faster than you, right? But imagine that. No matter how fast you accelerate, that car always seems to be going exactly 120 kilometers per hour relative to you. You accelerate to 150 and it still seems to be going 120 faster. You accelerate to 200, same thing. It's impossible, but that's exactly how light works. And here's the really crazy part. When Einstein realized this, that the speed of light is constant for all observers, he didn't try to explain it within our intuitive understanding of the world. He did something far more radical and courageous. He said, our intuitions about space and time are wrong, completely wrong. If the speed of light is constant, then time and space cannot be constant. They have to be flexible, elastic, relative. Two observers who are moving relative to each other literally experience different rates of time passing and measure different distances for the same objects. It's not an illusion. It's not a trick of perspective. It's literal. Time really does pass slower for someone who is moving fast relative to you. But our senses don't detect this because we never move fast enough in everyday life. The difference only becomes significant when you approach the speed of light. So our brains evolved in a world where these differences are so minuscule that they are irrelevant for survival. Why would our senses detect something that makes no difference to finding food or escaping a lion? And this is precisely where humanity's greatest mistake lies. We assume that if our senses don't detect something, then that something doesn't exist or isn't important. Look how many times we've fallen into this trap throughout history. For millennia, we thought the earth was flat because that's what it looks like when you look around. You don't feel the curvature. You don't see the curvature unless you're very high up. Your senses tell you, flat. For millennia, we thought the earth was stationary at the center of the universe because that's exactly what it looks like. The sun rises, moves across the sky, sets. The moon does the same. The stars rotate. Everything seems to be moving around us. Your senses tell you, we are stationary, everything else is moving. For centuries, we thought time was absolute. that a second here is equal to a second anywhere in the universe, no matter what. Why? Because in our everyday experience, clocks show the same time, no matter where they are or how fast they are moving, within the speeds we experience. For years, we thought space was just empty space, a stage where things happen. We didn't think that space itself could bend, stretch, ripple. Why? Because you can't see or feel the curvature of space-time. In each case, our senses deceived us. And not because they are defective. They do exactly what they are supposed to do. The problem is that we expect tools made for survival in the savannah to be adequate for understanding black holes, quantum mechanics, and the structure of space-time. It's like trying to use a hammer to perform brain surgery. The hammer isn't bad, it's excellent for driving nails, but it's utterly inadequate for medicine. Similarly, our senses are excellent for navigating the everyday world, but completely inadequate for understanding fundamental physics. So, what is the solution? How can humanity overcome this mistake? The answer is both simple and profound: mathematics and experiments. Mathematics is our way of thinking beyond our senses. When Einstein derived special relativity, he wasn't looking at complicated experiments. He was thinking deeply about what it means that light travels at the same speed for all observers, and using mathematics to follow that reasoning to its logical conclusions, no matter how strange those conclusions might seem. And here's the brilliant trick: mathematics doesn't care about what feels right to your intuitions. Mathematics simply follows logic. If you start with correct premises and apply logic correctly, you arrive at true conclusions, even if those conclusions completely violate your common sense. That's why Einstein could say things like, "Time passes more slowly when you move fast," or "Gravity is the curvature of space-time." Even though he never experienced these things directly, he followed the mathematics. But, and this is a crucial but, mathematics alone is not enough. You also need experiments. Because mathematics can take you to many places, and not all of those places correspond to reality. You need to verify. You need to test. And this is where modern science becomes absolutely beautiful. We create instruments that are far more sensitive than our senses. We build detectors that can measure time differences smaller than a billionth of a second. We build telescopes that can see light from galaxies billions of light years away. We build particle accelerators that can probe scales millions of times smaller than an atom. These instruments are extensions of our senses, but far more powerful. And when we use these instruments to test mathematical predictions, something magical happens. We discover that the universe is even stranger and more beautiful than we could have imagined. Take the GPS on your cell phone as an example. It works using satellites orbiting the Earth. These satellites have super-precise atomic clocks. But here's the problem. Because these satellites are moving fast, relative to you on the Earth's surface, and because they are in a region where gravity is a little weaker, time passes differently for them than for you. If the engineers who designed GPS hadn't taken Einstein's relativity, both special and general, into account, the system would have accumulated errors of about 11 kilometers per day. 11 kilometers. In a single day, your GPS would be completely useless. But because they correct for relativistic effects, your GPS works with meter-level accuracy. Every time you use GPS to navigate, you're relying on a technology that only works because Einstein was right about time being relative and space being curved. You're literally navigating through the consequences of relativity. And do you feel anything strange? No. Zero. Your senses tell you it's just a map showing you where you are. The bizarre structure of space-time operating behind the scenes is completely invisible to your direct perceptions. Here's another example that will leave you speechless: quantum entanglement. If you take two particles and entangle them quantumly, and then separate those particles, one goes to São Paulo, the other to Tokyo, they remain connected in a way that makes no sense to our senses. If you measure a property of one particle, say its spin, the other particle instantly knows what the result was and adjusts its own property accordingly. Instantly. No matter the distance. Einstein called this spooky action at a distance because it seemed too ridiculous to be true. How can two particles separated by thousands of kilometers be connected in this way? How does information travel between them? It can't be faster than light, because nothing can travel faster than light. But experimental tests show that entanglement is real. The particles really are connected in this bizarre way. The fundamental nature of reality is non-local in a way that completely violates our intuition about how things should work. And again, do you feel it? Do you experience quantum entanglement in your daily life? Of course not. But that's how the universe really works at a fundamental level. So, going back to the original question, what is the biggest mistake humanity makes in trying to understand the universe? It's an assumption that reality should make sense to creatures evolved to survive in the African savanna. It's confusing the map with the territory. Our senses are the map, a useful representation of reality optimized for specific purposes. But the territory, the actual physical reality, is far stranger, far richer, far more interesting than any map could capture. And here's the really profound part. Once you understand this, you realize that this mistake isn't limited to physics. We make this same mistake in everything. In politics, we assume that our perspective is obvious and natural, without realizing that it is shaped by our specific experiences and cognitive biases. In economics, we create models based on how we think rational people should behave, ignoring the fact that the real human brain is full of heuristics and biases that evolved for completely different purposes. In ethics, we often appeal to what feels right intuitively, without questioning where these intuitions come from and whether they actually lead to good results. In relationships, we assume that other people see the world the same way we do, and we get confused when they don't. The mistake is universal, relying too much on direct experience without questioning its limitations. But here's the hope, the beautiful thing about science and critical thinking in general. We can transcend our senses. Not deny them, they're still useful, but go beyond them. Newton did this when he realized that the same force that makes an apple fall is the same force that keeps the moon in orbit. His senses told him they were completely different things falling versus things circling in the sky. But mathematics revealed the profound unity. Einstein did this when he realized that space and time are aspects of a single thing, space-time, and that mass and energy curve this thing. His senses told him that space is space, time is time, and gravity is a force. But mathematics, and later experiments, revealed a deeper truth. Quantum physicists did this when they discovered that particles can be in multiple states at the same time until they are measured. Our senses tell us that things are definitely here or there, are this or that. But quantum reality is much stranger. And the most incredible thing? Every time we transcend our intuitions and discover something new about how the universe truly works, we gain power. Power to predict, power to build, power to transform. Relativity gave us GPS, precise nuclear medicine tests, and an understanding of the cosmos. Quantum mechanics gave us transistors, lasers, magnetic resonance imaging, and computers. Understanding electromagnetism gave us literally all of modern civilization: electricity, radio, television, the internet, and smartphones. So here's the final message, the most important thing you can take away from this conversation. Don't trust your senses when it comes to understanding profound truths about reality. Trust the scientific method. Trust mathematics. Trust carefully controlled experiments. Trust instruments that can measure things your senses could never detect. But also, and this is equally important, don't completely disregard your senses. They are the starting point. They are what motivates us to ask questions. When Einstein wondered what it would be like to ride a beam of light, he was using his sensory imagination to ask a profound question that eventually led to relativity. Science is not about denying our senses. It's about recognizing their limitations and building tools, both conceptual and physical, to go beyond them. And when you truly understand this, something changes in the way you see the world. You look at the ground beneath your feet and know it's mostly empty space held together by electromagnetic forces. You look at the sky and know you're seeing light that took millions or billions of years to reach you, showing you what the universe was like in the distant past. You look at your watch and know that time is passing slightly differently for you than for someone on top of a mountain. Reality becomes richer, deeper, more mysterious, and simultaneously more comprehensible through the tools of science. This is the beautiful paradox of physics. The more we learn, the more we realize how little our senses tell us about what is really happening. But also, the more we learn, the more powerful our tools become for understanding and navigating this reality that our senses could never capture on their own. So, yes, humanity's greatest mistake is relying too much on the senses. But humanity's greatest achievement is discovering how to go beyond them, how to build upon them, how to use reason, mathematics, and experimentation to reveal a universe far stranger and far more magnificent than we could ever have imagined just by looking around. And this journey, from creatures limited by their senses to explorers of fundamental reality, is, for me, the most beautiful story humanity has ever lived.